Good evening and welcome to the Design and Technologies Parents Information Evening. My name is Mr. Radford and I'm the head of the Design and Technology Department. Please feel free to contact me if you have any queries or questions following this video. At St Paul's, all students study a Design and Technology at Key Stage 4. And at St Paul's, we are fortunate to be able to offer an extremely broad choice of design and technology subjects. We provide the broadest choice of all of the secondary schools across Milton Keynes. Now, design and technology develops core skills for your child. These are skills that employers value immensely. Design and technology also covers other subject areas, from English to maths, applied science, ethics, and geography, with a focus on sustainability. If you have any questions about the Design and Technology programme of study, please feel free to contact your child's teacher using the details on this slide. Alternatively, please feel free to contact me at any point. The remaining part of this video will be focusing on the examined and coursework or NEA requirements of each individual Key Stage 4 Design and Technology programme of study. In this part of the video, I will be explaining to you how to be successful in your GCSE NEA. This is for students who study GCSE DT with electronics or fashion and textiles, or woods, metals and plastics, or graphics, papers, cards and boards. GCSE D&T is split into two sections, both worth 50%. The NEA, more commonly referred to as coursework, and the examined content. The examined content focuses on the core principles of D&T, which run throughout electronics, fashion and textiles, woods, metals and plastics, and graphics, papers, cards and boards. The NEA allows students the opportunity to focus on a specific material area. I'm here to give you a brief overview of the NEA, what it is, why you need to do it, as well as a quick look at what a typical NEA portfolio might look like. The NEA is a portfolio of work that will show your teachers how you investigated a specific need, problem or opportunity, and how you developed and tested a prototype that would solve that specific need. It must reflect how things happen in real time, what your teachers will refer to as a chronological portfolio. It must also respond to one of the three contexts or themes that are set by the exam board OCR each year. These have currently been released and your children are currently working on these. The portfolio of work that you produce accounts for 50% of your total GCSE grade. So why do the NEA? The NEA helps you to demonstrate your knowledge, understanding and skills through an iterative process that explores needs, creates solutions and evaluates how well these needs have been met. It helps you to develop the critical creative thinking skills that are required to manage and organise this process. It will help equip you with lifelong skills of problem spotting and problem solving and enable you to apply this to lots of different areas. This is a brief, concise example of an NEA portfolio. It is only 24 slides long and ranges from slide 1, which is initially exploring the three contexts released from the exam boards, through to slides 3, which is analysing existing products within that contextual area, through to slide 6, which is looking at model making. Slides 10, 11 and 12 are looking at development of an idea or a solution, Slides 13, 14 are a record of manufacturing, and slides 15, 16 and 17 are presenting a final prototype using CAD, a piece of software such as Google SketchUp or Creo Parametric, which we use at St Paul's. The remaining slides are looking at the effectiveness that this solution would have in its real life context and situation, an evaluation. Some top tips. Talk to others and get their opinions. Be clear in your portfolio who you have talked to and how you have taken on board their feedback and opinions. We refer to these in the PowerPoint template as decision times. Document everything as it happens. This will help you build up your real-time evidence. Focus on describing what you did, why you did it, and how it affects your project. Further help and support. Don't forget to document everything as it happens through the process, as this shows your real-time thinking and thought process. Focus on describing what you did, why you did it, and how it affects your project. Attend DT Club on a Wednesday after school in your DT room with your DT teacher. Some of my DT team will offer a tech club on a different night, but they will let your child know through its learning. Visit the OCR website and use the resources and guides that are available there. If you require any further help and support after this part of the video, please feel free to contact me on my St Paul's School email.
Hello and welcome to Food Preparation and Nutrition. Today we're going to look at your NEA. Why do the NEAs, what the NEAs are, and show you an example portfolio. So why do the NEA? You need to show that you have covered all of the areas in food preparation and nutrition. We have food, nutrition and health, food science, food safety, food choice and food provenance. Upon completion of this course, students will be qualified to go on to further study or embark on an apprenticeship or full-time career in catering or food industries. You'll show your knowledge and understanding, your creative thinking skills and problem solving. So what are the NEAs? You have two NEAs in food preparation and nutrition. A food investigation task and a food preparation task. The food investigation task is worth 30 marks and 15%. The food preparation task is worth 70 marks and 35%. That totals at 50. That, along with your exam, which is 50% also, is 100%. So, we have the first NEA. This will be introduced to you in September. NEA 1 is a food investigation task. It is 3 sections. Section A is the research, okay, where we plan the investigation and establish a hypothesis. Section B is a practical investigation where you actually carry out the science experiment. And section C is where we analyse and interpret the results. NEA 2, the food preparation task. This task is your final opportunity to put into practice all that you've learnt throughout the course. You'll create a portfolio which is no longer than 20 A4 pages and with a font size of no bigger than 12. The portfolio will show evidence of research in the task, which is worth 6 marks. That is where we analyse the brief and we carry out the research. Then we demonstrate technical skills. That is done by planning and carrying out 2 to 3 technical cooks. These cooks are complex cooks. They have to show complex skills such as jointing a chicken, filleting a fish, creating your own pasta from scratch, pastry from scratch, bread from scratch, okay, with different flavourings, different shapings, etc. Then you will plan your final menu. Your final menu will be 3 dishes in 3 hours. Because now you are cooking 3 dishes all together, you must create a dovetail plan. So that is a plan where all of them link into each other. Okay, you will be multitasking. You get 8 marks for the planning. Then we come to making the final 3 dishes in 3 hours. Okay, you'll be taken out of lessons for that time. You'll be with me and we will cook them all in one go. You will have planned with your dovetail plan, you will have that in front of you, and if need be, practice these cooks at home. Then we have the evaluation and analysis. That's worth 8 marks. So you will be evaluating your 3 final cooks, costings, sensory analysis, the nutritional value, so using food, explore food effect of life. So the research is worth 6 marks, technical skills 18, planning of the final menu 8 marks, making the 3 final dishes in 3 hours 30 marks, and then your last evaluation 8 marks. That totals at 70. When you add that to your 30 marks from your NEA 1, you have 100, which is 50% of your overall GCSE grade. You will then complete your written exam in the sports hall, which is worth 100 marks. Altogether, your whole GCSE is marked out of 200. And that is it. If you need any further help or guidance, I'm always here to answer any questions. Document everything that happens along the way. So when we are doing the technical cooks, we need to take pictures of all of those technical skills so that we can prove that you did it and that we've got evidence. Focus on developing your knowledge and skills throughout the course. So practice these things at home as well as actually completing it in school. Attend DT Club on a Wednesday. I'll be in the food room, and you can come in any time, any Wednesday, to either practice a cook or complete some written coursework. Use the resources and guides available at the AQA website and also on It's Learning. Contact me at any time via It's Learning message or email. Thank you and good luck.
Hello, I'm Mrs Dodd and I'm one of the engineering design teachers here at St Paul's Catholic School. I'd like to give you a general overview of the Cambridge National Engineering Design Level 1-2 course and how the final assessments are structured. The Engineering Design Certificate is a fantastic introduction to this field with a wide range of future education and employment opportunities available locally, nationally and globally. Many of the St Paul's students who have previously been successful on this course have progressed into engineering and design related careers, and currently several local companies support our courses to encourage students to continue with engineering studies, especially our female students. There are 4 units of work which all carry an equal 25% weighting of marks for the final grade. The first unit, R105, is a formal public examination. For the remaining 3 units, students showcase a combination of their design and technical knowledge together with designing and practical skills. Their evidence is submitted as 3 separate PowerPoint presentations. Careful time management must be applied. Students are required to submit work on a regular basis to ensure that they meet interim deadlines for work completion. So independent learning must be completed every week. First, the R105, which is a 1-hour examination. The exam is sat in January with a June resit opportunity offered. Fundamentally, the R105 underpins the whole course with a broad knowledge of the design process, so a thorough understanding of the topics, regular revision and exam practice is essential for success. The structure of the exam questions vary from simple technical recall, short statements, to longer written responses, where spelling, punctuation and grammar is also assessed. Critically, this knowledge is applied to all of the other 3 units. R106, this unit is submitted as a PowerPoint. And the initial focus of the R106 is about how design and production are intertwined. The first section relates to production systems and processes, product life cycles and design legislation. Research and product analysis follows, with students focusing on 2 or 3 products using a variety of research methods, assessing the strengths and weaknesses, then providing detailed summaries of their findings with their critical opinions and conclusions. And this unit is concluded with a detailed product disassembly where pupils demonstrate safe working practices in the workshop. Understanding and application of the manufacturing processes and design sustainability are key to success here, as they must fully analyse the individual components of their chosen product. Students develop a critical analysis thinking skills that are required to manage and organise this unit of work. So the R107. Again, this unit is submitted by students as a PowerPoint. So the R107 develops students' visual communication skills. A broad range of drawing skills and techniques must be demonstrated, ranging from hand-drawn sketches to sophisticated 3D computer-aided design images. All of the IT skills developed during these particular units are highly transferable skills. Not only across the school curriculum, they are equally applicable for future opportunities at sixth form and beyond. The R108 is also submitted as a PowerPoint. It incorporates project management and practical skills. Students will need to demonstrate their capabilities in organising their time to complete the production of a design prototype. Again, safe working practices in the workshop should be highly evident throughout this unit of work. Visual documentation with photographs, video clips and GIFs are a great way for students to show their evidence of this. This is an example of an R106 coursework for product analysis and research. So generally students submit approximately 20 to 25 slides of work. The R107, again presented as a PowerPoint, usually slightly less. Generally students submit approximately 15 to 20 slides of work for this particular unit. And moving on to the R108, similar content quantity is 15 to 20 slides of work for this particular unit as well. And this one is about design realisation and the modelling of the prototype. So the key pieces of information here for students are that they do need to document all of their work thoroughly and make sure that they are consistently adding to their unit of coursework to maintain the ongoing progression towards the completion and making sure that they hit deadlines. It's critical that they use technical information and subject-specific vocabulary throughout all of their PowerPoint slides. And on Wednesdays after school there is a design technology club so that students can access any IT facilities and workshop facilities to maintain that progression in their work. Resources, guides and information are available via the Cambridge National's Engineering Design Level 1-2 Award Certificate page on the OCR website. Additionally, the It's Learning School website has many resources specifically for this particular course.
Hello and welcome. I am Miss Gidman and I am a teacher of Engineering and Design Technology at St Paul's Catholic School. I'll be talking to you today about how to be successful on the Cambridge National Engineering and Manufacture course. I'll be briefly talking you through the 4 different units of work that make up the course and a guide to the work that is assessed in each unit. The units of work are R109, R110, R111 and R112. R109 is worth 25% and is an exam that is sat in the 1st January of Year 11. There is a resit opportunity for this the following summer. R110 is a coursework unit of work that pupils have been working on throughout Year 10 so far, and R111 and R112 are units of work they will be completing in Year 11. The course is graded in Pass, Merit, Distinction and Distinction Stars. It is a Level 2 course and pupils are aiming to achieve a Level 2 pass or above by the end of the course, so that's the equivalent of a grade 4 at GCSE. The R109 exam tests pupils' knowledge of the topics listed on this slide. The most successful pupils revise throughout Year 10 and 11 for their exam that is sat in the January. In lessons, pupils continually learn, practice questions, revisit the exam content, and it often crosses over with the content of other units of work. Pupils must thoroughly know all of the content on this slide. To miss a question or to have a gap in knowledge on this exam impedes pupils achieving a grade Level 2 pass or above. It is a shorter exam paper with less content, but the key is to know it all inside and out. In the R110 unit of work, pupils interpret an engineering drawing, plan a product's manufacture and use machine tools such as the engineering lathe and milling machine to manufacture a one-off prototype. Pupils video and document the product's manufacture and then compare their outcomes to the original engineering drawing that allows them to carry out quality control checks. They then consider other scales of production for the product and adapt their plan of making for the manufacture of the 1,000. A key focus in this unit is health and safety and how pupils plan and document how they are ensuring safe working practices. This work is continually assessed by the teacher and pupils receive regular feedback to act on. Being successful on the course involves pupils acting on this feedback to the best of their ability and ensuring the initial deadlines are met with work that is complete. Club After School on Mondays for Year 10 into Year 11 is highly advised for pupils to come and get more one-to-one practical time on the lathes and to dedicate to making their units of work thorough and detailed. The R111 unit assesses the points on this slide. Pupils use computer-aided design software to draw the product that they made in R110 and then program the CNC lathe to carry out the task of manufacturing this while planning and documenting their work. The skills pupils gain on this course with the hand tools skills, machine tools knowledge and the CNC tools really help them to carry their study on at A-level and beyond. It mirrors the advances in CNC in industry and helps pupils to look at the moral and ethical side with things such as the effects on the workforce of robotics and CNC advancements. In the final, shorter R112 unit, pupils look closely at the quality control process. They research tools and equipment used to ensure quality and accuracy, and they use examples from previous units of work to document this. This unit therefore relies on pupils having strong R110 and 111 units of work, and to have worked accurately on these units, documenting everything they did. Alongside R110 and 111 units, the teacher writes a witness statement, and this is used. It mentions how accurately and how independently pupils were able to work on their practical tasks. So being independent and accurate are both core skills for this course. So the next slide, I just summarise the things that you need to be successful. So engineering pupils need to meet deadlines, work hard, be resilient, be self-motivated learners, work accurately, work independently. So successful engineers do attend club on Mondays and often show an interest in design and engineering outside of the classroom with wider reading and interest in smart and modern advancements in materials and processes. We want our engineers to question products that they see in everyday life and to be able to describe how they are made in industry. Okay. Any questions that you have whatsoever, or pupils have, you're more than welcome to contact me via It's Learning or via email. Thank you very much.